Alright, so in our last video we talked about surface area of cylinders. Now we're going to talk about the surface area of a cone. When we're working with cones, we have one circular base and then what we call a vertex. So kind of think of things like your ice cream cones, sometimes those paper cups at those little water fountain type plate, you know, kind of like a Dixie cup, but it's in a cone shape. Anyway, so things to know, like we did with the last one, our base is a circle. This time it's just one circle, not two circles. And then we have what's called a vertex. And the vertex is the point furthest from the base. Farthest from base. So in our picture, that's going to be this right here. That's our vertex. It's farthest from the base. Again, we have that lateral surface. And so that is the curved surface. So in our picture, it looks like a triangle, but the lateral surface is all of this, not including our base of the circle, but because it goes all the way up to the circle. So things to keep in mind. And then we have slant height. So this is the distance from the vertex to the base. So we call it slant height because it's this right here. This side, this is our slant height. And then if we talk about just height, that's the perpendicular, the length of the perpendicular. Oops, helps if I can spell length. E-N-G-T-H. Length of the perpendicular segment. So from here, straight down to our radius. So the length of the perpendicular segment from the vertex to the base. And normally, as long as this is a vertical, or not a vertical, but a right cone, then it will hit right at the center of our radius. So it's that length, that perpendicular segment from vertex to base. So height goes from the vertex straight down, slant height from the vertex down the slant of the triangle to our base. All right, so next slide. Finding the surface area of a cone. So again, surface area is the sum of each surface, the area of each surface. So we're going to have the area of the circle plus the lateral area. Alright, so the lateral area is going to include the circumference. Well, it would start with the circumference of the circle and then times our slant height. But because there is, if you remember doing the pyramid, we were multiplying that by a fraction or dividing, however you want to think about it. Well, the lateral area of in a pyramid, we divided by 1/2. Well, that takes out the 2 from our radius, and that probably got all confusing. So to find the lateral area, it's just going to be pi times our radius times our slant height. So letters to know. R is going to be radius. And the cursive L is slant height. Oops. H-E-I-G-H-T. And why is it not the cursive H? Because normally, especially in physics and stuff, they do use the cursive lowercase h for regular height. So we also know that the area of the circle is pi r squared. And so our surface area formula is going to equal pi r squared plus pi r slant height. And that's our formula. All right, so then from here, let's use it. Again, I like to start with what do I know? To find the surface area of a cone, I need radius and slant height. I know the diameter, so I'm given a diameter of 10 inches. So then I know my radius is going to be 10 divided by 2, which equals 5. And my slant height is this 15 inches because it's from the vertex to the base. So that's going to be 15. From here, I'm going to plug into the fact that surface area equals pi r squared plus pi r slant height. Oops. And so then I'm going to have pi times 5 squared plus pi times 5 times 15. And so then as I simplify, 5 squared is 25, so I have 25 pi plus, and 5 times 15 is 75, so 75 pi. And then 25 plus 75 is 100, so I have 100 pi. Again, this is what we would call our answer in terms of pi. I've simplified it all the way down, and pi is still part of my answer. It does want us to use 3.14, so we're going to take 100 times 3.14, and we will end up with 314 inches squared, because since it's an area, it's in units squared. So inches squared as our surface area for our cone-shaped arrangement box. And so that is how you find the surface area of a cone. Until the next video.